Hi there! In this video, we're going to talk about how to find a counterexample. So first, let's talk about what a counterexample is. It's an example that proves my statement to be false. And I only need to have one example to prove any statement false. So just a quick something to note. In geometry or in mathematics, when you're proving a statement or a theorem or something to be true, you have to be able to prove it true for every entire situation, occurrence in the history of time, basically. There cannot be one instance where your example or your statement that you're trying to prove is false. But if I'm trying to prove something to be false, all I have to do is find one instance where my statement is not true and I proved my whole statement false. So a lot of times it's easier to prove something to be false than it is to be true because I only have to find one thing to prove it false as opposed to look at all scenarios for something that is true. So that one thing that's false that we're looking for is called the counterexample. So I have 4 different examples for you where we're going to look for a counterexample. Every single one of these examples below, and there's, like I said, 4 of them, there is a counterexample for. Some of them have more than one counterexample, and some of them only have one. So let's get started. And I'm a visual person, so if they're going to give me a bunch of just a sentence here, I always have to draw out the picture. So first one says, if the measures of angles P, Q, and R are supplementary. So to me, I'm just going to draw it out like this. So here's a straight line. Supplementary, I know, means adds up to 180 degrees. So I'm going to say that this is angle P, this is angle Q, and this is angle R, just for sake of this problem so I can see it. Then one of the angles must be obtuse. Okay, remember, obtuse means bigger than 90. So if I have 3 angles that add up to 180, does one of them have to be bigger than 90? Well, no. I mean, it could be. But can I find an example where all 3 numbers are smaller than 90 degrees that still add up to 180? All right, well, what if I did 50 and 50 make 100, and then 80 makes 180? All of those numbers are smaller than 90 degrees, so here is a counterexample. So P would be 50 degrees, Q would be 50 degrees, and R would be 80 degrees. It doesn't matter if you picked this one was 80 degrees and these two are 50. You just want to find one example that proves your statement wrong. Okay, next. This one says, if the measure of angle WXZ. So like I said, I'm pretty visual. I have to draw this out. So here's WXZ. They're telling me that my whole angle is 50 degrees. And this is definitely not drawn to scale because I drew this as an obtuse angle, but it doesn't matter because I'm just trying to find an example. The point Y is in the interior. So Y is somewhere in the middle, like this. And then they're saying that WXY, so WXY, this angle is 25 degrees and this angle is 25 degrees. Okay, so basically this says I have an angle that is a big angle that's 50 degrees and I have 2 smaller angles that add up to 50, so they both have to be 25. Well, not necessarily. I mean, if it was an angle bisector, if it cut it in half, but what if this one was 40 and this one was 10? Or vice versa. So you could even say this one was 1 and this one was 49. There's a bunch of different examples you could use here. So I'm going to go with 1 and 49. So WXY is 1 degree and this one would be 49 degrees. Okay, next. If the area of a rectangle is 24 centimeters squared. All right, so I got a rectangle here. And my area is 24 centimeters squared. It says my length has to be 2 and my width 2 centimeters and 12 centimeters. Okay. And we know the area is the same as length times width, so 24 is the same as length times width. Is 2 times 12 the only 2 numbers you can multiply together to get 24? No. I could say, well, 1 times 24 is 24. We already have 2 times 12, 3 times 8, or 4 times 6. I'm going to pick 4 and 6. So I'm going to say 4 centimeters and 6 centimeters. And it doesn't matter which one you pick for the length or width. You could switch them. We're just, remember, trying to find one example that proves this to be false. Okay, last one. If angle 1 and angle 2 are complementary. Okay, complementary means adds to 90. So I'm going to draw a 90-degree angle. Complementary angles, then one angle must have a measure less than 45. Okay, so if I draw in an angle here, here's angle 1 and here's angle 2. So if they're less than 45, so like if this one was 20 and this one was 70, then one angle, this angle would be less than 45. Is there any way to make it so that one of the angles is not less than 45? This one only has one counterexample, and that is if they are both 45. 45 is not less than 45. 45 is equal to 45. So if this in case was an angle bisector and cut my angle in half, where both angles equaled 45 degrees, then that would be your counterexample. So remember, you're just looking for one example. Some only have one, like this last one, but the first 3 problems, there was a bunch of counterexamples you could have used. Good luck. Let me know if you have any questions.